Hello, everyone. Today we will learn the composition and control strategy of AC charging system. Task to introduce a customer to Geeky Car for Second store to buy pure electric vehicles. Want to understand the pure electric vehicle charging. As a Car for Second store a sales manager, please take the customer to Geeky Automobile After Sales Service Store. Choose Geeky Hardihood EV450 for its introduction to the pure electric vehicle charging system through the Geeky Car AC charging system cognition to troubleshooting basic learning, so that customers have a more comprehensive understanding of the charging system. We have 3 learning objectives for this course, which are 1. Understand the components of an AC charging system. 2. Familiar with AC charging interface specifications and maintenance, etc. 3. Familiarize yourself with control strategies for AC charging systems. We will learn today's lesson in 3 parts. 1. AC charging system overview. 2. AC charging port awareness. 3. AC charging control strategies. Part 1. AC charging system overview. 1. Define. AC charging means that the voltage input to the vehicle from the power grid is AC, which can be 220 VAC one-way or 380 VAC three-phase. The AC charging port of the new energy vehicle is connected through the AC charging pile, and the AC power is boosted and converted to DC power by the onboard charger, OBC for short, and then rectified into the voltage required by the vehicle through the rectifier module inside the OBC to charge the power battery of the vehicle, which is known as AC charging, or also known as slow charging. 2. Makeup. Vehicle charger, charging cable and sockets, vehicle controller VQ, AC charging post. 3. Role. 1. The onboard charger is designed to convert AC power into DC power to charge the battery according to the control instructions. 2. The AC charging socket is the vehicle's connection to the external power grid, with an input of 220 VAC or 380 VAC. 3. Vehicle controller is implemented to monitor the state of the vehicle and send control instructions to the vehicle charger to make it work normally or stop working, control its working current and voltage, etc. It is the control brain of vehicle charging. 4. The AC charging post is a component of the vehicle that connects to the external power grid and provides 220 VAC or 380 VAC power directly to the onboard charger. It has the function of detecting the state of the vehicle and the power grid, and connecting or disconnecting the power supply to the vehicle. When charging with an AC charging post, the charging power is higher. That is, the charging time will be shorter. Part 2. AC charging port awareness. 1. AC charging port, the charging component for connecting the active cable to the electric vehicle, which consists of 2 parts, the charging socket and the charging plug, is the necessary equipment for the conductive charger, and the charging plug is structurally coupled to the charging socket during the charging process to realize the transmission of electrical energy. As shown in the picture, CC charging connection confirmation, CP control guidance, L1 firewire, pay protective earthing, N0 line, L2 and L3 reserve. 2. Measurement of AC charging port. Warm tip. When the power of the charging pile is lower than 7 kilowatts, the AC power will charge the power battery through the onboard charger in the bidirectional inverter charging and discharging technology. When the power of the charging pile is higher than 7 kilowatts, the AC power will charge the power battery directly through the bidirectional inverter charging and discharging technology. Connect the wiring harness between the AC charging port and the high-voltage electrical control assembly. 3. AC charging port maintenance. 1. With the vehicle turned off and the entire vehicle unlocked, open the charging port hatch and charging port cover and check for blockages and deformations. 2. Visually inspect the terminal reads for breakage. Broken ones need to be replaced and dealt with. Charging ports beyond the warranty period need to be replaced at your own expense. Part 3. AC Charging Control Strategy. 1. AC Charging Process. As shown in the picture, 1. Power battery charging. The charging pile is connected to the charging port through the charging line, and the vehicle charger converts AC into direct current to charge the power battery. 2. 12 volts battery charging. The power battery outputs direct current, and the DC or DC converter converts high voltage direct current into low voltage direct current to charge the battery. 2. AC Charging CC or CP Control Strategy. As shown in the picture, 1. The CC signal is the judgment signal of whether the charging plug and charging socket are connected or not, and at the same time, the vehicle determines the capacity of the wiring harness by judging the RC resistance value based on the signal value of CC. 2. The CP signal is to determine the power supply capability of the power supply unit, which is determined by the duty cycle PWM value. 3. Each resistance value and duty cycle PWM value in the electrical schematic must meet the standard requirements, and the controller must be judged according to the standard to meet the charging needs of the vehicle in the market. 3. Charge CC Control Logic. 1. In off gear. When the charging gun is plugged in, the CC detection changes from suspended to grounded, and the vehicle plug and vehicle socket connection status is determined by detecting the resistance between 0.3 and P, confirming the current rated capacity of the charging connection device cable and lighting the charging connection indicator. 2. The maximum power supply current of the current power supply device is confirmed by measuring the duty cycle of the PWM signal at the detection point 2. And the vehicle is allowed to charge when the vehicle detects the duty cycle of the charging gun output. 3. When the vehicle is in AC charging mode, the onboard charger detects the CC and CP signals of the AC charging interface charging gun insertion and conduction signal and wakes up the BMS, which wakes up the onboard charger and sends commands to charge, and at the same time closes the main relay, and the power battery starts to charge. 4. CC Sensing. Determine if CC is connected by detecting the access circuit ground. If a voltage drop is detected, then CC is considered connected. The CC signal determines the charging current allowed by the charging gun cable specifications. 5. CP Sensing. When the charging gun is successfully connected, the CP signal is a duty cycle signal, and the maximum AC input current allowed by the charger can be derived from the incoming signal of the CP detection line, and the CP signal determines the maximum output current of the charging gun. 6. Charging conditions for AC mode. 1. High and low voltage circuits are properly connected and must not exceed the load limit of the home power grid. 2. The power supply of the charger is normal and the charger works normally. 3. Charge wake-up signal output is normal. 4. Normal communication between charger, VQ, and BMS. 5. Power battery core temperature 0 degrees centigrade less than X less than 45 degrees centigrade. 6. The difference between the maximum voltage and the minimum voltage of a single cell less than 0.3 volts. 7. The difference between the maximum temperature and the minimum temperature of single battery less than 15 degrees centigrade. 8. Insulation performance greater than 500 ohm volts. 9. Maximum actual single unit voltage not greater than rated single unit voltage 0.4 volts. 10. High and low voltage circuits are properly connected and must not exceed the load limit of the home power grid. In this course, we have studied the AC charging system of new energy vehicles from 3 aspects: overview of AC charging system, cognition of AC charging port, and AC charging control strategy. I believe you have a more comprehensive understanding of the charging system. And this is the end of this course.